Hello, this is Team 26 of AI-based software engineering lecture. In this video, we would like to present about our project, GA-based test data generation for DOM Purify. DOM Purify is an open-source XSS sanitizer library written in JavaScript. For the detailed explanation of DOM Purify and XSS attack, we left the link of our previous proposal video link and some useful explanation of our project's background knowledges on the description of this video. So please check out. The goal of this project is to generate test cases that can concisely and sufficiently exercise the sanitizer measured in terms of code coverage. So, based on seed test data collected from domain knowledge, we applied genetic operators to generate various complex test cases. Then we constructed a test case generator for testing DOM Purify based on genetic algorithms. Those are the steps of experimental approaches and methods. We also covered them on the proposal video, but we will explain in more detail on this video based on our experience. So those are the experimental approaches and methods that we used. I will explain them step by step. So we first understood and learned about HTML tags and sanitization logic of DOM Purify. We first searched for HTML tags and attributes. HTML tag is the minimal unit of element composing a HTML document, and HTML attributes are the additional values given to tags that configures the tags or adjust their behavior. Then we looked for the sanitization logic of DOM Purify's implementation. It first parses given HTML document by placing HTML tags on each node. Then it iterates over each node, sanitizing elements by comparing its structure with malicious patterns, and sanitizing attributes by removing forbidden attributes and invalid values. After the end of the iteration, it returns the sanitized HTML document. Secondly, we developed a framework for parsing and manipulating HTML test cases. We used Python as our implementation language and used Beautiful Soup for the HTML and XML parser, allowing traversal and modification of parse tree. Thirdly, we extracted code coverage of DOM Purify's implementation with V8 coverage extraction functionality utilized with C8 report library. C8 report library helped us to use V8's code coverage extraction functionality by showing the coverage as a report. And lastly, we designed fitness function and genetic operators to generate test cases. The fitness function is as follows. The better the coverage of the test case is, the better it is. Also, shorter test case is considered as better one. And the coefficient beta multiplied here to make the effects are reflected equally. For the genetic operators, we have seeding, crossover, and mutation operators. For the seeding operator, we randomly generated HTML documents with tags and attributes with random string values. The HTML document size is determined with those properties: height, width, and attribute count, attribute value length. Also for the crossover operator, we randomly swapped HTML tags and attributes and HTML subtree and all attribute of HTML tags. And for the mutation operator, we deleted, added, replaced, or shuffled random HTML element, or we deleted, added, replaced random attributes, or we injected random by the random position, stringifying them. The hyperparameters used for genetic algorithms are as follows. We used linear ranking for selection with S equals to 1.5 and 0.8 crossover rate and 0.1 mutation rate and population size 10.